Hi, welcome to video 6.1a. I know we just started chapter 4, but this relates to chapter 4. It's called slope fields. Okay, at the beginning of chapter 6, 6.1, it's differential equations. This one page will be the last of differential equations, and then we'll get into slope fields, which is really what we're interested in. So here's an example from page 411 where you're given a differential equation and its solution. And you're asked to verify the solution. Now, if you look at this differential equation, you would never be able to solve this differential equation in high school. You'd have to major in math and take a course in differential equations to learn how to solve this because it's a second derivative and it's very complicated. But they're not asking you to solve the differential equation. They've already solved it for you, but what they want you to do is verify. So basically, what you're going to do is simply figure out what the second derivative is for y equals cosine x, and then you're going to substitute that in, minus, and then you'll substitute in with y is equal to, and you should end up with the left side equals the right side. So to get to the second derivative, I'm going to have to find the first derivative of cos x, which is negative sine x. The second derivative, therefore, is negative cosine x. And now I just plug that information into the given differential equation. So we found out that the second derivative is negative cosine x minus, we know that y is equal to cosine x, and sure enough, the left side equals the right side. Okay, so now slope fields. Okay, so this is right out of the book. Solving a differential equation analytically can be difficult or even impossible, as you saw in that last one. However, there is a graphical approach you can use to learn a lot about the solution of a differential equation. So consider a differential equation of the form y prime equals f of xy. What they're telling you here is you might end up with y prime equals just in terms of x, or maybe y prime is just in terms of y, or maybe y prime is in terms of both x and y. So you could have y prime equals x squared, you could have y prime equals y cubed, you could have y prime equals x squared plus y cubed, where f of xy is some expression in x and y. At each point xy in the xy plane, where f is defined, the differential equation determines the slope, because that's what the derivative is. It's the slope of the solution at that particular point. If you draw short line segments with that slope at selected points in the domain of f, then these line segments form what's called a slope field or a direction field for the differential equation. Each line segment has the slope as the solution curve through that point. A slope field shows the general shape of all the solutions, which is the plus c, and can be helpful in getting a visual perspective of the directions of the solutions of a differential equation. So what we have is there's two sets of homework, actually. There's the back in section 4.1 is the first time they actually defined that we didn't do those questions, but now we will. And in this section in chapter 6, page 412, numbers 53 to 72. So again, you're going to be given a differential equation. You're going to be given y prime or dy dx equals a function maybe just in x, just in y, or in both x and y. Instead of actually solving the differential equation, which might be impossible or very difficult, we draw a bunch of tiny tangent segments at the given grid points. Now, a grid point or a lattice point is an integer, comma, an integer. So here's an example. Let's say you're given dy dx equals x squared. Now, I know you can solve this differential equation easily, but let's do it using a slope field. Plus, the question will be, what's the slope field? So in this particular case, because it's only x's and no y's, it won't matter what the y coordinate is because the slope at any point is only going to be the square of the x coordinate. So any point negative 2 comma something, the slope will be 4. Any point negative 1 comma something, the slope will be 1. You're just plugging your x value into this differential equation. Then what you do is you draw all these little tiny segments. So at negative 2 comma whatever, our slope is 4. So here, all these slopes are 4. Any point negative 1 comma something, the slope is 1. As you can see, any point 0 comma something, the slope is 0. Any point 1 comma something, the slope is 1. Any point 2 comma something, the slope is 4. And then what you can do, for example, if you pick an initial condition, a 0.01, This represents, if you drew all of them, you'd have the family of curves, but this is the particular curve through the point 0, 1. And what you got to do is kind of stand back and look and see what the general shape of the graph is. So you draw the particular solution through that initial condition, okay? If we actually did solve this differential equation by hand, we would get x cubed over 3 plus c. Here's x cubed over 3 plus 0. Here's x cubed over 3 plus 1. Here's x cubed over 3 plus 2. X cubed over 3 minus 1. And you can see that we kind of get a picture of what those graphs would look like without actually solving it. Okay, and they'll actually ask this on the AP in the free response. They'll give you a differential equation. They'll give you a certain number of points, 6 points, 9 points. They won't give you 100 points, that's for sure. And they'll ask you to actually draw a slope field through those points. So you are given these points right here. The formula for the slope, the dy dx, the differential equation, is 2x plus y. So 2 times negative 1 plus 1, 2 times negative 1 plus 0, etc., all the way down the line. And then you simply go to each of those points and draw the corresponding slope. So at the point negative 1, 1, we have a slope of negative 1. At the point negative 1, 0, we have a slope of negative 2. At the point negative 1, we have a slope of 3, etc. And that's all they're going to ask you to do. Okay, now just if they give you a question, a multiple choice question, and they say which of the following is the slope field for the given differential equation, there are some little shortcuts. If there are no y's at all, then what's going to happen on each imaginary vertical line, all the slopes are going to be the same. As we saw in our example, let's say the slope at negative 2 comma whatever is 1. That means all of the points negative 2 comma something are going to have a slope of 1. If it's only in terms of y and there are no x's, for example, here it won't matter what the x is because this is just a function of y, and let's pretend that the slope at negative 2 is 0. So all the points, x, whatever the x is, all the points that have a y value of negative 2 are all going to have a slope of 0. So that can help you pick. If you look at page 256, number 52, they are going to ask you, I believe... Oh, that's page 256. Let me pause for a second. Okay, welcome back. Okay, so here's page 256, number 52. Here's the directions. Okay, they actually introduce slope fields within a question. So here's all the same definition we talked about. Sketch 2 approximate solutions of the differential equation on the slope field, which they're giving you, one of which passes through the indicated point. And then use integration to find the particular solution of the differential equation. And then you can actually draw it on your calculator. Okay, so the first part is forget the differential equation. Just look at the slope field. Here's your initial point. And the question is, can you kind of follow this and then see that the graph through that point would look like this? Right? Does that make sense? Okay, so that's the particular solution through negative 1, 3. They said to pick another point, so I picked this point, that point, that point, and then I drew the same thing. Part B is actually solve the differential equation. So we're going to separate the variables. Remember, y is on one side, x is on the other. We're going to integrate both sides. The integral of 1 dy is y. The integral of x squared is x cubed over 3. The integral of negative 1 dx is negative x. Don't forget the plus c. And now we have an initial condition, so we plug that in. We replace the x's by negative 1 and the y by 3. And we find the value of c, and now we can rewrite this as the general solution of the family of curves, but because they gave us an initial condition, we can find the value of c and get a particular equation. Okay, and then you would graph that on your calculator to see that it equals the same thing. And that's the end of video 6.1a.